Hello everybody, welcome into another lesson. So today we are going to continue talking about using matrices to solve systems of equations. Today we're going to be taking three variable systems of equations which have three equations and convert those into augmented matrices and solve them that way. So much like the two variable systems of equations, you're going to take all the coefficients here on your three variable systems of equations. You're going to have three rows since you have three equations. Take the coefficient of your x variable, then your y variable, then the c variable in each row. And then to the right of the augmentation line, you'll put the values for what each of those equations are equal to. So it's much like doing a two variable system, only we have a three variable system. You're going to do it the same way. We're going to continue to use Gauss-Jordan Elimination with back substitution. And we're actually going to do back substitution twice because the goal is to get the matrix into row echelon form, where for a 3x3 system, your leading coefficient in the top row is still 1, and then you could have whatever coefficients on the x and y variables, but the first digit in your second row should always be 0. And then the leading digit in the second row should be a 1, and then you could have whatever coefficient on the z variable. Then in the third row, your first two digits should both be 0, and then the leading digit in the third row should be a 1, which would denote the value of your z variable. What you'll do is you'll find that value of the z variable, then you'll put that into your second row, which this would really be 1y plus dz equals f. Put that z value in and solve for y. Now that you know both y and z, then you'll substitute those into the top row, which this would really stand for 1x plus ay plus bz equals c. You would substitute both of those in and solve for x. And then the goal is you'll get an ordered triple. That's the solution to the system. So that's how you do row echelon form for a 3x3 system. Yesterday we talked about 2x2 systems. Today we're going to deal with a 3x3 system. So let's get started with our first system here. We have 2x plus 6y plus 3z equals 2. Then we have x plus 3y plus z is going to be equal to 1. And then we have x plus 5y plus 2z is equal to -1. So now that we have our system here, let's go ahead and convert this into an augmented matrix. So you have three equations, that means you'll have three rows. So for your first row, take your x coefficient, which is 2, your y coefficient, which is 6, your z coefficient, which is 3, then form your augmented line, which would be 2, and then continue on for the next two rows. Your second row, the x coefficient is 1, the y coefficient is 3, the z coefficient is 1, and then to the right you'll have 1 to the right side of the augmentation line. Now for your third row, your x coefficient is 1, your y coefficient is 5, your z coefficient is 2, and then to the right side you'll have that -1. So we have just set up the augmented matrix that represents the system. Well, first thing I'm going to suggest, if you're ever able to, you can swap out one of these rows for the first row if the coefficient on your x variable in the first row is not a 1, because you want the first digit in the first row to always be 1. You want that to be a leading 1. Swapping rows is an elementary row operation. It literally does not change the result of the matrix, it just puts it in a different order, but you'll get the same result. So we're going to swap rows 1 and 3. To denote that, you just put a double arrow between the R1 and R3 to denote that we're swapping rows. So let's go ahead and do that here. If we do that, row 3 becomes row 1, so you'll have 1, 5, 2. Then to the right side of the augmented line, you'll have -1. Row 2 we're leaving alone. That's 1, 3, 1, and 1. Now row 1 just became row 3. So we'll have 2, 6, 3, and 2. Now this is nice here because the leading digit in the first row is a 1. We've already settled the first row. But we need to deal with rows 2 and 3. We need to start out by making the first digit in rows 2 and 3 a 0. That's how we're going to start getting this on the way to row echelon form. And the good news is you can do more than one row operation at a time. For example, if I take the negative of row 1 and add to row 2, I'll make the first digit in row 2 a 0. So we're definitely going to take the negative of row 1 plus row 2. Now, if I decide to take -2 times row 1 and add it to row 3, I'll make the first digit in row 3 also 0. So let's do that. -2 times row 1 plus row 3. Let's go ahead and get our new matrix by doing so. So row 1 we're leaving alone. That's 1, 5, 2, and then the -1. Now, we're going to deal with row 1 and 2. If I take -1 plus 1, that's just going to give me 0. If I take -5 plus 3, that'll give me -2. If I take -2 plus 1, that'll give me -1. If I take -1, that'll give me +1, plus that 1, that'll give me 2. And then we've dealt with row 2, now let's deal with row 3. So rows 1 and 3 we're going to deal with. So if I take -2 times 1, that gives me -2, plus that 2, that'll make 0 in the third row for our first number. Now -2 times 3 is -2 times 5 is -10, plus 6 is -4. And then if I take -2 times 2, that gives me -4, plus 3, that gives me -1. Then -2 times -1 is +2, plus 2 gives me 4. So now I have a matrix in where the first digit in both the second and third row is 0. We're on the right path, but we're not there yet. Before you try to get a leading 1 in the second row, use this -2 to your advantage and use it to make the second digit in the third row become 0. What do I mean by that? If I take -2 times the second row and add that to the third row, the second digit in the third row will also become 0. So we're going to take -2 times row 2, we're going to add that to row 3. Let's go ahead and form our new matrix that way. So first row, yeah, leave that alone. You have 1, 5, 2, -1. Leave your second row alone for the time being, at least. Now your third row. So -2 times 0 is 0, plus 0 is still 0. Now if I take -2 times -2, I get +4, plus -4, that turns that into 0. Now if I take -2 times -1, that gives me +2, plus -1 would give me +1. If I take -2 times positive 2, that's going to end up giving me negative 4 plus that 4, which would give me 0. So what do you know? I have a leading 1 in the third row. That's great. And I have a leading 1 in the first row. And now the first 2 digits in the third row are 0. We're almost to reduced row echelon form, but not quite. What you want to do now, in order to get this truly into row echelon form, is you want to turn that leading digit from negative 2 into positive 1. So you got to take negative 1/2 of the second row. So let's go ahead and do that. Negative 1/2 of row 2, perform that operation, we'll get the final matrix, which should be in row echelon form. So leave the first row alone. That's already row echelon in the first row. Negative 1/2 of row 2, so negative 1/2 times 0 is still 0. Negative 1/2 of negative 2 turns into positive 1. There's that leading 1. Negative 1/2 times negative 1 is positive 1/2. Negative 1/2 times negative 2, negative 1/2 times positive 2 is negative 1. Alright, so now we got a leading 1 in the second row, and then the third row we just leave alone. Well, what does this tell you here now? We definitely have this in row echelon form, since the leading digit in each row is a 1. This third row denotes that z equals 0. So z is equal to 0. That's going to make our lives a lot easier. Now, we're going to take that z equals 0, we're going to come up to the second row. This second row, you have a coefficient on the y variable, which would be 1. This would tell you y plus 1/2 of z equals negative 1. Well, z is 0, so literally y would equal negative 1. So now we have both y and z solved. You're going to take both of those values, come up to the very top row, put it into the top equation, which would be x plus 5y plus 2z equals negative 1. Well, now you're going to end up having x plus 5 times that y value of negative 1 plus 2 times that z value of 0 equal to negative 1. You would end up getting x minus 5 equals negative 1, which would give you x equals 4. Now we know the value to all three, x, y, and z. We found the ordered triple. That's the solution to the system. It's going to be 4, negative 1, 0. That is the ordered triple. That is the solution to the system of equations. And if you don't believe me, just stick this into any one of these equations up here, the ordered triple, all those values for x, y, and z, you should get a true statement on both sides. So 2 times 4 is 8, plus 6 times negative 1. So you'd have 8 minus 6, which is 2, plus 3 times 0. Well, 2 plus 0 is 2. 2 equals 2. So yes, 4, negative 1, 0 is the ordered triple. That's the solution to this matrix. Now I got 5 more. All right, what's the next one about? Sort of similar. We have 2x plus 6y plus 3z, this time equals 8. We have x plus 5y plus 5z is going to be equal to 1. We have x plus 3y plus z equals 3. So there is your new system of equations. Go ahead and convert this into a 3 by 3 matrix since you have 3 equations. So first row, you'll take that 2 on the x, that's 6 on the y, that 3 on the z, form your augmented line. You'll put that 8 to the right of the line of augmentation. Now form your second row, take that 1 on the x, the 5 on the y, the 5 on the z, and then put that 1 to the right of the line of augmentation. Third row, take that 1 on the x, the 3 on the y, the 1 on the z, then put that 3 to the right of the line of augmentation. And there you go. There is your nice matrix to represent the system. Again, take one of these rows. I would take one of these rows and swap it with the first row because it's going to make your life easier if the first digit in row 1 is a 1. You want to have a leading 1 right out the gate if you possibly can. That's going to make your life a lot easier. So why don't we once again swap row 1 and row 3? So that's exactly what we're going to do. We're going to swap rows 1 and row 3. We'll form a new matrix that way. Really, it's going to be the same thing. It's just we swapped rows. So row 3 becomes row 1. So we'll have 1, 3, 1, and then we'll have 3. Row 2 is being left alone for a moment. 1, 5, 5, and then 1. And then now row 1 became row 3, so you'll have 2, 6, 3, and then 8. So there's your rearranged matrix just by swapping rows. It's the same thing, we just swapped rows, that's all. Okay, so what we're going to do now, again, start out by getting, we have a leading 1 in the first row. We need to make the first digit in both the second and third row become 0. Make the first digit become 0. So if I take negative of row 1 and add to row 2, I can definitely make that happen in row 2. And then if I take negative 2 times row 1 and add that to row 3, I can also make that happen in row 3. Okay, so let's do that. Let's form our matrix. So leave row 1 alone. That'll be 1, 3, 1. And then 3. Now, row 1 and 2, to deal with row 2, if I take negative 1 plus 1, I get 0. If I take negative 3 plus 5, I get positive 2. If I take negative 1 plus 5, I get 4. If I take negative 3 plus 1, I get negative 2. So there's my new second row. Now let's deal with rows 1 and 3. We're going to make the first digit in row 3 a 0. So if I take negative 2 times that 1 and add it to 2, negative 2 times 1 is negative 2 plus 2 is also 0. Now if I take negative 2 times 3, that's negative 6, plus 6, that's also 0. And then if I take negative 2 times 1, that's negative 2. Add that to 3, I get 1. And then if I take negative 2 times 3, which is 6, add that to 8, I'll get 2. Well, what do you know? This actually worked out very nicely. We're almost in row echelon form. Because not only did we get rid of the first 0 in the third row, not only did we get rid of the first digit and make that a 0 in the third row, we actually were able to make the second digit in the third row a 0, which is nice if you can do both at once. It doesn't often happen that way, but when it does, it's nice, because now the leading digit in the third row is a 1. So all we need to do to convert this to row echelon form is make that leading digit in the second row a 1. Since it's a 2, that means we need to take half of row 2. So take 1/2 times row 2, get your new matrix. So leave row 1 alone. You have 1, 3, 1, and 3. Now half of row 2, so half of 0 is still 0. Half of 2 is 1. Half of 4 is 2. Half of negative 2 is negative 1. Then leave your third row alone. You have 0, 0, 1, and 2. Now this is in row echelon form since the leading entry in each row is a 1. In the third row, that 1 represents the coefficient on the z variable, which means you get a z value of 2. So now we know z. We're going to put that into the second row. The equation of the second row, the coefficient on the y is 1, so this would be y plus 2z equals negative 1, which means y plus 2 times that z value of 2 equals negative 1. So y plus 4 equals negative 1. That means y is equal to negative 5. So now we know both y and z. We're going to take both of those, put that into the top row, which gives you the coefficients for all your x, y, and z variables. This would end up being x plus 3y plus z is equal to 3. So take your x, which we don't know yet, plus 3 times your y value of negative 5, plus your z value, which was positive 2, set all that equal to 3. That would give you x minus 15 plus 2 equals 3, which would give you x minus 13 equals 3, which would give you an x value of 16. So now we know all three values. We found the order triple. That's the solution. It's going to be at 16, negative 5, and 2. That would be the order triple. That's the solution. 16, negative 5, and 2. So stick those into any of these three equations, the original equations. If you're in doubt, you should get a true statement on both sides to confirm that this order triple is your solution. 4 more equations, 4 more systems, and we're done. For today, at least. All right. So the next system is going to be 2x plus 10y equals 28. X plus 3y plus 4z equals 22. Then we have x plus 5y minus z equals 10. So here's our system of equations. So we need to take all this and put this into an augmented matrix. You have 3 rows, you have 3 equations, so you'll have 3 rows. So take the coefficient on your x variable in the first row, that's 2. Coefficient on the y variable is 10. And then you don't have a z variable, so the coefficient on the z variable by default is 0. And then on the right side of the augmented line, you're going to have 28. All right. Now, of course, the second row, the coefficient on x is 1, the coefficient on y is 3, coefficient on z is 4, and then you have 22 to the right. And then third row, coefficient on x is 1, coefficient on y is 5, coefficient on z is negative 1, and then you have 10 to the right. So there is your matrix for this system. If you're ever missing a variable, the value for the coefficient on it is always 0. That makes sense. 0 times z is just 0. So that works. Well, let's look at the top equation. Yes, if we can, we want to make the leading digit again in the first row a 1. But we don't need to swap rows, because if we look here, 2, 10, 0, and 28 all have a common factor of 2. We can settle the top row by simply taking 1/2 of row 1 and coming up with a matrix right there. We don't even need to swap rows this time. So half of 2 is 1, half of 10 is 5, half of 0 is still 0, and then you have half of 28 is 14. They worked out with nice even numbers and no fractions. Then we left the second and third rows alone for now. So the second and third rows for now haven't changed, but the top row has. Notice we have all 1s to work with. This is going to make life a lot easier. We have a leading 1 in the first row, but we need to make the first digit in the second and third row become 0. So if I take the negative of row 1 and add that to row 2, that'll make the first digit in my second row a 0. And if I do the same with row 3, take negative of row 1 and add that to row 3, that'll also make the first digit in my third row 0. So why don't we do that? We'll form the new matrix here. So row 1 is getting left alone. You have 1, 5, and 0. Then you have 14. Alright, so now let's deal with row 1 and 2 to make the first digit in row 2 a 0. If I take the negative of 1 and add that to 1, I get 0. If I take the negative of 5 and add that to 3, I get negative 2. If I take the negative of 0 and add that to 4, I get 4. If I take negative 14 and add that to 22, I get positive 8. So there's my new row 2. Let's deal with row 3. We're taking the negative of row 1, adding that to row 3, so negative 1 plus 1 is still 0. Now negative 5 plus 5 is also 0. Negative 0 is 0, plus negative 1 is still negative 1. And then negative 14 plus 10 is going to be negative 4. Well, what do you know? We did it again. We actually got the first 2 digits in row 3 both to be 0. So we took care of a step right there. Now, first thing I'm going to recommend, we can actually do both at once if you think about it. Because the leading digits in both the second and third row are not 1. We have that in the first row, but in the second and third row, the leading digits are not 1. In order to make the leading digit in the second row 1, we got to take negative 1/2 of row 2. And then in order to make the leading digit in row 3 a positive 1, you just negate row 3. And then just perform those operations and you'll get a new matrix. So row 1 gets left alone. 1, 5, 0, 14. Now let's see, negative 1/2 times 0 is still 0. Negative 1/2 times negative 2 is positive 1. Negative 1/2 times 4 is negative 2. Negative 1/2 times 8, that's negative 4. Now just negate row 3. Negative 0 is still 0. Negative 0 is also 0. Negative negative 1 turns into positive 1. Negative negative 4 turns into positive 4. Now we have a matrix in row echelon form, which will make our lives a lot easier. So the z value is definitely 4. We found z to be 4. Now let's put the z value into the second row. This equation in the second row would end up being y minus 2z equals negative 4. So take y minus 2 times that z value of 4, set that equal to 4, which gives you y minus 8 equals 4, which would give you y equals 12. So we have z equals 4, y equals 12. Now we're going to take both of those, put that into the first row. Well, we don't have a z term, but we certainly have a y. So this would basically be x plus 5y is equal to 14. Since the z variable has a coefficient of 0, we don't even worry about that. This would become x plus 5 times that y value of 12 would equal 14, which would give you x plus 60 equals 14, which means x is going to equal negative 46. So now we know all three values. So we'll put this into an ordered pair notation. You'll end up get ordered triple rather. The ordered triple that's the solution is negative 46, 12, 4. So that would be the ordered triple that would become the solution. So negative 46, 12, and 4 is the ordered triple that's your solution. So yeah, you can get some wild numbers sometimes. All right, 3 more. We're halfway there. So we have x plus 4y minus 2z is equal to 3. We have x plus 3y plus 7z is going to be equal to 1. Then we have 2x plus 9y plus z equals 8. So there is our new system of equations. This time, of course, we're going to put it into an augmented matrix again. 3 equations, so you'll have 3 rows. Coefficient on the x in the first row is 1. Coefficient on the y is 4. Coefficient on the z is negative 2. Then form your augmented line. Put that 3 to the right of the augmented line. Now do your second row. Coefficient on x is 1. Coefficient on y is 3. Coefficient on z is 7. Then put that 1 to the right of the augmented line. Third row. Coefficient on x is 2. Coefficient on y is 9. Coefficient on z is 1. Put that 8 to the right of the augmented line. There's your augmented matrix that represents this system of equations. Notice this time the leading digit in your first row is already a 1. So we're really not going to have to do anything with row 1. That's pretty nice. We don't even got to swap rows or multiply it by anything or divide it by anything. So our goal now is to go ahead, since we have a leading 1 in the first row, get rid of these 2 digits in the second and third row, make your first digit in the second and third row a 0. So if I take the negative of row 1 and add that to row 2, I will definitely make my first digit a 0. Then if I take negative 2 times row 1 and add that to row 3, my first digit in that row will also become a 0. So let's do that and form our new matrix. So row 1 gets left alone, 1, 4, negative 2, and then you have the 3. Now let's deal with negative row 1 plus row 2. So negative 1 plus 1 is 0. Negative 4 plus 3 is negative 1. Negative negative 2 is actually positive 2, plus 7 is 9. Negative 3 plus 1 is negative 2. Now let's take negative 2 times row 1, add that to row 3. So negative 2 times 1 is negative 2 plus 2, which is also 0. All right. Take -2 times 4, which is -8, plus 9 is 1. And then go ahead and, let's see, -2 is +4, plus 1 is 5. And then -2 times 3 is going to be -6 plus 8 is 2. Now, if I were you, looking at this here, because yes, our goal is for sure to go ahead and get rid of the second digit in the third row and make that a 0. We have two ways we can do this. We can either add row 2 to row 3 and make that happen, and then have to turn around and negate row 2, or we can just go ahead and swap rows 2 and 3 now, and then we can just add the 2 rows and be done with it. I'm going to swap rows 2 and 3, personally. It don't matter which way you do it. I find it easier to swap rows. So we're swapping rows 2 and 3, so row 1 gets left alone. 1, 4, -2, 3. Now row 3 becomes row 2, so you'll have 0, 1, 5, 2. Then row 2 became row 3. You'd have 0, -1, 9, and -2. Okay? At this point, we are ready to proceed and add row 2 to row 3 to make the second digit in row 3 become 0. So we're going to add row 2 to row 3. We'll go ahead and form our new matrix. So row 1 still gets left alone. 1, 4, -2, 3. And then you'll end up, of course, leave row 2 alone. 0, 1, 5, 2. Alright, so 0 plus 0 is still 0. 1 minus 1 is also 0. 5 plus 9 is 14. 2 minus 2 is 0. We are almost to row echelon form because the first and second rows both have a leading 1. But the leading number in the third row is 14. We need it to be a 1. So go ahead and take 1/14 of row 3, and you'll end up getting this into row echelon form. So again, leave rows 1 and 2 alone. 1, 4, -2, and then 3. And then, of course, second row leave alone. 0, 1, 5, 2. All right, 1/14 of 0 is 0. 1/14 of 0 also 0. 1/14 of 14 is 1. And then 1/14 of 0 is 0. Now we have this in row echelon form because the leading digits are 1 in all 3 rows. So the third row tells you that z has a value of 0. So z equals 0. That makes it nice. The second equation now tells you that y plus 5z equals 2. Well, if z is 0, if we put that in, you'll literally just get y equals 2. So we have z equals 0 and y equals 2. Now that we know both y and z, let's put that into the top row. The equation of that would be x plus 4y minus 2z equals 3, which would be x plus 4 times that y value of 2 minus 2 times that z value of 0 equals 3. Well, the 2 times 0, it's gone because it's 0. You literally would just get x plus 8 equals 3, which would give you that x equals -5. So now we know x, y, and z. We have the ordered triple. That's the solution, which would be at negative 5, 2, and 0. That is the ordered triple. That would be your solution. Negative 5, 2, and 0. I just got 2 more problems here. Alright, 2 more. We're almost there. We have x minus y plus 3z is equal to 6. We have x minus 2y equals 5. Then we have 2x minus 2y plus 5z equals 9. So there's your new system of equations. Go ahead and set up your augmented matrix. 3 equations means 3 rows. First row, coefficient on x is 1, coefficient on y is actually negative 1, coefficient on z is 3, and then to the right of the augmented line, you'll put that 6 there. Now, second row, coefficient on x is 1, coefficient on y is negative 2. We don't have a z variable there, which means the coefficient on z is 0. And then the 5 will go to the right of the augmented line. Third row, coefficient on x is 2, coefficient on y is negative 2, coefficient on z is 5, then the 9 goes to the right of the augmented line. Well, I'm going to definitely suggest something here. What I would do, yes, it's true that row 1 has a leading 1, but notice the z value is 0. In that case, I would swap rows 1 and 2. Why don't we go ahead and swap rows 1 and 2? That's going to make our lives a little bit easier. So we are swapping rows 1 and 2. If we do that, row 2 becomes row 1. You'll have 1, negative 2, 0, and then 5. And then row 1 becomes row 2. So 1, negative 1, 3, 6, and then row 3 we're just leaving alone. 2, negative 2, 5, and 9. Alright. So, now that we've done that, we have a leading 1 still in the first row. But you want to make the first digits now in the second and third row both become 0, right? So if I take negative of row 1 and add that to row 2, that'll make that happen in the second row. Then if I take negative 2 times row 1, add that to row 3, that'll make it happen in the third row. So we're going to do all that now, and we'll form the new matrices. So row 1 is being left alone. 1, negative 2, 0, and then 5. Alright. Negative of row 1 plus row 2. So negative 1 plus 1 is 0. Negative negative 2 is positive 2. Plus negative 1 is positive 1. Then we have negative 0 plus 3 would be 3. And then we have negative 5 plus 6 is going to be positive 1. Alright, now negative 2 times row 1 plus row 3. So negative 2 plus 2 is also 0. Okay, and then negative 2 times negative 2 is going to actually be positive 4, plus negative 2 turns into 2. And then, let's see, negative 2 times 0 is 0, plus 5, that's 5. Alright, negative 2 times 5 is negative 10, plus 9 is negative 1. So, not only are the first digits in rows 2 and 3 0, but the leading digit in row 2 is now also 1. So we can actually leave both rows 1 and 2 alone from now on. Now the next goal is to make the second digit in row 3 also a 0. That should be pretty easy. If I just take -2 times row 2 and add that to row 3, I'll get that result. So take -2 times row 2, add that to row 3, that should put us where we want to be. So leave row 1 alone, 1, -2, 0, 5. Alright, let's see. Leave row 2 alone, 0, 1, 3, 1. Alright, -2 times 0 is 0, plus 0 is still 0. -2 times 1 is -2, plus 2 is also 0. Alright, -2 times 3 is -6, plus 5 is going to be -1. -2 times 1 is -2, plus -1 is -3. Alright, we're almost to row echelon form, but we have a -1 for our leading digit in row 3. It needs to be a positive 1. Well, that's easy. All we got to do is negate row 3 and we'll be in row echelon form. So let's form the final matrix here. 1, -2, 0, 5, 0, 1, 3, 1, and then negative of row 3, you still have 0, 0, -1 becomes +1, -3 becomes +3. Now the matrix is in row echelon form since the leading digit in each row is 1. This tells you here that z equals 3. So we got our z value of 3. Now all we have to do is take that z value of 3, put it into the second row, which makes the equation y plus 3z equals 1. So take y plus 3 times 3, set that equal to 1. Y plus 9 equals 1, which means y equals -8. So we got a y value of -8. We know y and z now. We could put both of those into row 1. So this equation in row 1 would read x minus 2y, 0z, so we don't even consider z then, is equal to 5. Which means you'll take x minus 2 times your y value of -8, set that equal to 5, which would give you x plus 16 equals 5, which could only mean then that x would equal -11. And now we have the ordered triple that's going to be our solution since we have x, y, and z. The ordered triple would be -11, then -8, and then 3. So the ordered triple that's the solution to this system of equations would be -11, -8, and 3. And I got one more and we're done for the day. All right, last one for the day. A little bit different. We have x plus 2z equals 4. We have x plus y plus z equals 6. Then we have 3x plus 3y plus 4z equals 28. All right, so let's go ahead and set up our augmented matrix for this system of equations. 3 equations means 3 rows. So in your first row, coefficient on x is 1. You have no y variable, so the coefficient for your y is 0, but the coefficient on z is 2. And then draw your augmented line, and to the right of that, you'll put that 4. And then, let's see, what you're going to do next is do the second row. Coefficient on x is 1, coefficient on y is 1, coefficient on z is 1, and then you'll end up putting that 6 to the right of the augmented line. Third row, coefficient on x is 3, coefficient on y is also 3, coefficient on z is 4, and then you have the 28 to the right of the augmented matrix. Alright, so good news is we have a leading 1 in the first row, but we need to make the first numbers in the second and third row become 0. So if I just take the negative of row 1, add that to row 2, then if I take negative 3 times row 1, add that to row 3, I can make that happen in both rows. So let's go ahead and do such. So row 1 will be left alone. You have 1, 0, 2, and 4. I think I need a new marker for real. I don't think this can wait, even though we're on the last exercise. This is pretty bad. There we go. Alright, so negative of row 1 plus row 2, negative 1 plus 1 is 0. Negative 0 is just 0, plus 1 is 1. And then we have negative 2 plus 1 is negative 1. And then negative 4 plus 6 is going to be positive 2. Okay. Well, now the good news is the leading digit in both rows so far is a 1. So we're almost there. Now, negative 3 times row 1 plus row 3. So negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 0 is 0, plus 3 is 3. Alright, and then negative 3 times 2 is negative 6 plus 4. That's negative 2. And then negative 3 times 4 is going to be negative 12 plus 28 is 16. Alright. So at least now the first 2 digits in the second and third row are 0. We have a leading 1 in the second row. Now we just need to make the second digit in the third row also be 0. So if we take negative 3 times row 2 and add that to row 3, we should be able to make that happen. So row 1 gets left alone. You have 1, 0, 2, 4. Row 2 gets left alone. You have 0, 1, negative 1, 2. Now, negative 3 times row 2 plus row 3. So negative 3 times 0 is 0, plus 0 is also 0. Negative 3 times 1 is negative 3 plus positive 3 is 0. Negative 3 times negative 1 turns into positive 3, plus negative 2 turns into positive 1. And then negative 3 times positive 2 is negative 6, plus 16 is going to be 10. So we actually now got this in row echelon form because the leading digit in each row is a 1. So this is telling you right here z equals 10. Alright, now take that z value of 10 and then put it into your middle row. this would be telling you that y minus z equals 2. So that means y minus 10 equals 2, which would end up giving you that y equals 12. We know y and z, we can now put those into the top row. Well, we have a 0 value for our y coefficient, so this would literally be x plus 2z equals 4. So we have x plus 2 times that z value of 10 equals 4, which means x plus 20 equals 4, which gives you an x value of negative 16. Now we have the ordered triple that's going to be our solution. It'll be negative 16, 12, and 10. So the ordered triple that will be the solution to this system will be negative 16, 12, 10. And that's it for this lesson. Next lesson, we're actually going to go back to two variable systems of equations. But this time, we're going to convert matrices into reduced row echelon form. That'll be a way to get more to the direct solution of each variable without doing back substitution. So I hope everybody has a great night. Take care.